A survey of 150 employees at a company asked which type of transportation the employees use to get to work. The types of transportation and some of their percentages are shown on the circle graph. How many more people use a car than ride a bicycle to get to work? See, how many more people use a car than ride a bicycle to get to work? Okay, so basically that's going to be like the difference between my car riders and my bicycle riders, right? All right. Another thing to pay attention to here. Let me read this again. I'm going to look for more important information. A survey of 150 employees at a company asked which type of transportation the employees use to get to work. The types of transportation and some of their percentages are shown on the graph below. Okay, so we know there are 150 employees total, right? This whole circle has 150 people. And I know that I need to subtract the car minus the bicycle. Now, the bicycle just so happens to be the only mode of transportation that we do not have a percentage for, right? But we know that the total percentage here, it's gonna be 100%, right? So let's add them up and see what's left out. 38 plus 32 plus 20. Let's see, 38 plus 32 is gonna be, well, 8 plus 2 is 10, right? So that would be 70, and then the 7 plus 2, so 90. So we have, so what's here? The train, the car, and the bus. All together, those represent 90%. So that means the bicycle must be 10%, right? So let's subtract this. 38% is our car. We're going to subtract our bicycle, which is 10%. And that would be 28%. So that's our difference. And notice that is an answer choice, 28. But this is wrong because 28% of the people, 28% is the difference between cars and bicycles. It's not the number of people. To find the number of people that represents that difference between car and bicycle, we need to use a percent proportion. So let's see. We have x out of 150. That's our part over our whole. Equals 28 over 100. That is what we need. So I personally like to simplify and look for relationships. So I'm going to do that here. I'm going to divide both of these by 4. So then I have 7 over 25. And then I know 25 times 6 is 150, right? So then 7 times 6 would be 42. So I'm going to go with answer choice C. I know that some of you guys like to cross multiply and divide, and you could do that too, right? One thing I would encourage you to do before you get started cross multiplying and dividing is at least do a little simplifying first so that you're working with smaller numbers. So for example, 150 and 100 are both divisible by 10, right? So we could make this 15 and we could make this 10. And then we could go even further if we want to, because these are both still divisible by 5. 15 divided by 5 is 3, and 10 divided by 5 is 2. So let me rewrite this proportion as x over 3 equals 28 over 2. Now, if you want to cross multiply and divide, this is not too bad, right? Although, do you really have to? Because 2 times 14 is 28, right? You could just do 3 times 14. Okay, but I know you want to cross multiply and divide. So now that we've simplified, let's do that. Let's just be sure we get 42 this way also. So I'm going to do 28 times 3. That's 84. Now I need to do 84 divided by 2. And that's 42. And that's what we wanted, right? So we had 2 ways to get our answer 42. I want to be sure that you know also that there are more ways than that to get this answer. For example, I could have found the percentage of car riders by solving this proportion. And then I could have found the percentage of bicycle riders by solving this proportion. And then I could have subtracted those 2 values after finding those 2 different parts, right? After finding the number of car riders and the number of bike riders, I could have subtracted. And guess what I would have gotten? I would have gotten 42. So there are multiple ways to this right answer. Just be sure that the one that you are using is reasonable and answers the question completely.